Part 1. The Big. 1. Clusters of galaxies are far more numerous than previously thought, and may be the fundamental condensations of matter in the universe. George Abel, The Distribution of Rich Clusters of Galaxies, 1958. Galaxy clusters. Long before it was understood what spiral and elliptical nebulas were, astronomers, especially Charles Messier, 1730 to 1817, a Frenchman who catalogued them so that they wouldn't confuse his search for comets, noted that they are not distributed uniformly across the sky. Rather, they tend to be concentrated into groups of a few and clusters of hundreds or more, a property noticed and remarked upon by British astronomer Wilhelm Herschel, 1738 to 1822, who presciently noted that the system we inhabit is likely very similar to spiral nebulas. A century and a half later, in the 1920s, studies of groups of clusters of galaxies were revolutionized by Edwin Hubble's demonstration that spiral and elliptical nebulas are galaxies like the Milky Way, located at distances of millions of light-years, which implied that these clusters of galaxies are in fact systems of enormous size. The tendency of galaxies to cluster together has been confirmed as larger samples of galaxies have been compiled. The first modern catalog of galaxy clusters, published by UCLA astronomer George Abel, 1927 to 85, in 1958, contained 2,712 rich clusters of galaxies found by the National Geographic Society Palomar Observatory Sky Survey. A rich cluster is defined as one containing more than 50 galaxies. New surveys have mapped the distribution galaxies out to distances of several billion light-years. The most comprehensive of these is the Sloan Digital Sky Survey, SDSS. This survey has used the Sloan Foundation's dedicated 2.5-meter optical telescope at Apache Point Observatory in New Mexico to obtain deep multicolor images covering more than a quarter of the sky, and to create three-dimensional maps containing more than 1.2 million galaxies. These large-scale maps of the universe, when projected into 2 dimensions, resemble road maps. Galaxies line up in filaments that crisscross intergalactic space like superhighways. Connecting these are smaller roads, and between these are regions of low population density, the cosmic countryside. At the crossroads where multiple filaments converge are clusters of galaxies, the cosmic megacities. The size of these clusters is daunting. Light, which travels at 186,000 miles per second, takes a little longer than a second to reach Earth from the Moon, and 8 minutes to reach Earth from the Sun. Light from the center of our Milky Way galaxy must make a journey of 25,000 years to reach us. Even that is fast compared to the time required for light to cross a galaxy cluster, about 2 million years. Clusters are the largest gravitationally bound bodies in the universe. The road-like filaments may be larger in sheer size, but they are not coherent bodies held together by gravity. Like metropolises on Earth, cosmic megacities do not originate fully grown, but are assembled from smaller clusters over billions of years. Unlike on Earth, where economic forces strongly influence the formation of cities, gravity is the principal driving force in the creation of galaxy clusters. As astronomers have recently learned, the effects of gravity on the evolution of a cluster can manifest in unexpected ways. The space between the urban cores, or galaxies, in a cluster is not empty. It is filled with diffuse gas left over from the formation of galaxies, heated to tens of millions of degrees by the slow gravitational collapse of the cluster. When gravity began to pull galaxies and the clouds in which they are embedded together to form clusters about 11 or 12 billion years ago, the slow collapse heated the intergalactic gas to tens of millions of degrees. This enormous gas cloud contains about 5 times the mass of all the stars in all the galaxies in the cluster.